Class is now starting. All attendees are in listen-only mode.
Good morning, everyone. My name is Chris Hall. I'm one of the Inventor product managers, and we want to welcome everyone to our channel readiness this morning. This morning, we're going to be talking about Inventor 2019.2. We're going to be introducing Inventor tolerance analysis, which is going to be in addition to the product design and manufacturing collection. And from there, we're going to hand it over to my partner, Lars Christensen, and he's going to talk about generative. And then we will move into a Q&A session from there. So one of the areas what I want to start with is over the last 3 years, we've had a significant investment in Inventor and Vault. And the investment is, it's the voice of the customer. And as you can see on the screen, we've had probably 100 to 200 customer success enhancements alone for Inventor and Vault in the last 3 years. So with that in mind, we want to look at 2019.2, which continues that same cadence. And basically, we made Inventor better with every release, 2019, 2018, while we continue to make it better with the dot releases. So continuing along the same theme that we've been working on for the last couple of years, we want Inventor to be a professional grade tool. We want the experience to be the best in the industry. And we also want to make sure it's connected, not only to products like AutoCAD, HSM, and those, but also to the cloud for those who wish to take access, or for those who wish to access those capabilities. So if we start with professional grade, one of the first things that we want to draw to your attention is some of the productivity improvements that have come with Frame Generator, which will be introduced in the 2019.2. What you'll see is the File tab itself has new naming file defaults for Generator. So under the application options, and basically in the file naming defaults dialog, you'll be able to click Add Attribute Drop Lists to configure your naming scheme. So adding a level of flexibility to when you want to create frames. The next part that moves into is frame creation. Now, the option to select multiple frame members for miter, the option for notch to select multiple frame members, and also a new selection and editing behavior to introduce to the change command. So in previous releases, we couldn't select or edit the attribute of reused components. Now you can select members of those group, modify the distance, rotation, angle values. All group members participate in a size or family change. If we move on, more enhancements. So one of the key things that's been, a big ask from our community is Content Center. One of the areas that we've addressed and this is a kind of adds to this, is we address performance. Now what we want to do is we also want to address search. So in this example here, we're going to have an advanced search and basic are now located within the quick search. You can now save that search query when results are displayed. Also, we continue to invest in tube and pipe. In the past, you could only author parts with a maximum of 10 connections. Now you can go up to 30 connections. Let's take a look at 2D. We've talked about 3D in the 3D space. Let's talk about 2D. One of the key areas of focus is performance. So we want to be able to, one of the areas was updating performance for cut views. And how we did that is that only the affected parts are updated. And this adds a level of speed. Also, presets. You'll notice a theme here that this is a productivity enhancement where you can set up presets now so that you can quickly add weld symbols, end fills, and surface texture symbols with with much less effort than before. Also, we improved overlay. And in the overlay, you no longer need to use a positional representation. When you create an overlay view, you can now use let me rephrase that. So you don't have to use positional representation to create an overlay view. Now you can use any view representation to create that overlay view. It's most useful when the position of the components doesn't change, but you want to emphasize a particular part or assembly in the view. And there was a small segment in the video that actually showed this. It was really quick, and if need be, we can go back and address that at the end. Okay, let's move on to the overall Inventor experience. One of the areas is model browser access. So there are times where you'll open Inventor, you'll open a part, and the feature tree is not there. So what we've done is we've enabled a plus sign in the upper left-hand corner to allow our users to access the environment or the particular assembly, modeling, whichever environment they're looking for quickly. Also, what we've done is we've added a section, solid texture. And what you see is in the application options color tab, the section solid texture allows you to specify a texture map. Now you can differentiate parts in your assembly when you section it much easier. The next one is an exciting one, where what we're going to talk about here is spell check. So the format text dialog box now provides Inventor with a spell check functionality. When it's turned on, a reg squiggly line, just like Word or some of the other tools you're used to, it displays underneath the text and it indicates the word is not in the active dictionary. Then you can right click and access options for managing the selections. And you'll notice also when you go into the application options that spell check now is on by default. So this is just a start of where we wanted to add spell check to the format text. Look for more as time moves on where we can expand this. A few quick notes. So in the past, things when we released, you would notice that there would be a README. Those are now been renamed to release notes, and they are in the help page. And you will see that there's an Inventor release notes and an Inventor release notes for 2019 and the subsequent dot releases that have been released in the last year for 2019. So how will the users access this? First of all, they'll be able to access it through the desktop app. Secondly, they can also access it through the account portal. So one of the key things is when is this going to be available? So 2019.2 will be available for subscription users starting next Tuesday. There we go. Kill this here. Okay, moving on. So for the last 18 months or so, with product design and manufacturing collection, we've been continuing to add value. So not only have we been adding value to Inventor through these subscription releases like we just talked about, we also added Inventor HSM, Nastran. Earlier this year, we added nesting. So with that continued theme, what we want to introduce to all of you is Inventor Tolerance Analysis. Inventor Tolerance Analysis will be directly integrated. It will be launched on November 5th. And on November 29th, a demo data set will be available that will also have a video and data set for you to either play the video or walk through the demonstration with your customers. About 2 weeks ago, 2.5 weeks ago, you should have received an announcement in the channel news that announced Inventor tolerance analysis as a new part of the product design and manufacturing collection. There was also some links to an FAQ of the product, how we're messaging it, an overview video, customer-facing PowerPoint, and the PowerPoint we're going to be looking at here is a subset of that, as well as the brain chart. On the right-hand side of the screen, you'll notice define a tolerance stack up. What this represents is a guided tutorial that has been created and will go live to all subscription users next week in guided tutorials. The second example there will be a data set that's going to be available to our channel, which is a caster wheel. And this will have both a setup that shows a complete set of stack-ups, multiple stack-ups that demonstrate the various analysis types you can use. And we'll also have a finished version to make it even easier to talk to, as well as a video. So let's get into some of the more details. As a lot of you are aware, we talk about these 4 key things: competitive pressures, development schedules in product design, development shortening, increasing complexity and customer demands, lowering costs, new technologies, and also introducing even new production capabilities. So we talked about this a few minutes ago. This is the powerful integrated solutions, and tolerance analysis is going to be an additional one. Let's talk about an example for a minute. Why is tolerance analysis important? If you look at this transmission example, the key thing, think about the key aspects of this. Number one, the parts need to be manufactured correctly to appropriate tolerances so that they fit together. If this transmission does not fit together like a clock, it can have many downstream negatives that can happen. Pre-wear of the gears, things not meshing correctly, even shifting slippage, all sorts of mechanical issues can develop. Also, good stack up parts also flows down into the drawings and makes them more accurate. Above all, what tolerance analysis is going to allow our customers to do is also look at, well, where can we reduce costs? Can we increase or decrease the tolerance in certain areas? A great example of this transmission is a gentleman, subject matter expert, was talking to us recently and gave us an example of a transmission. A transmission has roughly 2,000 stack-ups in it, and they were doing this manually and on a board. Well, the challenge was engineering came back and said, we need you to take 10 millimeters out of this. Well, because they had the stack-ups, they were able to appropriately take out the 10 millimeters out of key components that could actually be shortened, which actually in the long run is going to save design time by working from that level. So what are some of the causes of dimensional variation? Tool wear, temperature, deflection. I think the transmission's a perfect example of that. And also the machine precision, how precise something is machined. So this graph here is really interesting once you really start thinking about it. When we're designing parts and we can just have a part and we get a finished turn, you can see the cost is right about mean. But as I add additional processes to it, the costs exponentially increase. So the advantages are we want to reduce prototypes, we want to increase product performance, reduce warranty issues, and above all, profitability, so reducing costs. So what are some of the tools that our customers are using today in industry? Typically, with the data that we've seen, hand calculations and Excel spreadsheets are the top two areas that our user community leverages to do tolerance stack-ups. Also physical prototypes where they're physically measuring parts. And then there are some software applications, and software application adoption was quite low when it came to the overall question asking our user community, what do you use? So just a quick overview, Inventor tolerances analysis, it's fully integrated in Inventor. It'll help you calculate the cumulative effects of dimension and tolerancing, also giving you statistical root sum squared worst case, as well as some advanced results like CPK, sigma, yield, and DPMO. Above all, being able to communicate then with detailed reports that help collaborate with other areas of the business. So let me launch Inventor here, background. And one of the things that I want to take advantage of while I have your attention is, I'm not going to show a video. I want to show you, all of you live, how this works, how easy it is. So with it being fully integrated, what we'll do is we're going to open up this mixer assembly here. Now, there's two particular areas that we want to solve and look for where there could be a level of failure. If you look at our part here, one of the key areas is we don't want any slop or variation between this face and this face on the shaft. And you'll notice that the bearing sits on each one of those. So if we go into our environments tab and the tolerance analysis, you'll notice one of the first things that comes up is you'll have a feature panel on the right side, and I can go ahead and create a new stack up. So our first selection, so keep in mind, you don't have to solve the loop right now. What are the faces, or what are the parts of the faces that I want to determine what the best tolerance is going to be, or through the stack up? So if we look at this and we just come in here, grab that top face, and we're also going to grab the top face of this. Okay, now what you'll see is now what I need to do is I need to select an annotation plane. I can easily come in and select a system plane, and you'll notice I have a dimension of 3 thousandths. Now, one of the things to take note of here is one path found. What it did is it looked at the mates and it used the mates to create my tolerance loop. Now in here, what you'll notice in our different results, let's slide this over here. You'll notice right now we're solving for worst case. One of the key factors to look at, or key data points here, is on this end plate, we have GD&T. Applied. That information was used and linked in the stack up. Also the housing itself as well. And you can see right now that I'm between 1,000th and 6,000ths of an inch. But if I change to root sum squared for a minute here, you can see, from that particular result, I'm in pretty good shape. But let's go back to worst case, and let's see if we can make a quick adjustment to see if we can get a better fit. So let's actually reduce this to 2 thousandths. And one of the things you're going to notice is with that highlighted, it highlights the 2.207 over here. as soon as I select that, now I'm within 0 and 5 thousandths, which is the exact range that engineering wants me in with a worst case study. Another area, and this is, I want to make sure that this distance between this shaft here and the shaft on the motor is consistent. So what I can do is I can back out, and you'll see we have stack up number 1. We'll go to stack up number 2 here. Pick that face, and that face, again, you'll pick a plane. So it's pretty consistent. Here we're at 30 thousandths, 300 thousandths. Again, look at the stack up. So the loop is using the mates. Select that. You notice again, it's whenever you see the chain, it's linked back to my GD&T. So let's go in here. Let's open. Let me finish this here. And what we will open here, let's open one of our most recent examples. This is a vane pump. Now, the goal in this vane pump is, an example is, imagine I get a data set, or our customers acquire a data set that has no intelligence, it's a dumb solid, but you still need to check the stack up on it. So once I start a stack up, all right, now I can create a new stack up. What I'm going to take a little different approach here, where I want to create the loop manually. So if I select this face and this face, because this is the critical area we want to make sure we control our tolerance. My annotation plane, I'm actually just going to pick that part right there. You'll notice it says 1 path found. Well, if I go to select, now it says what are the mating faces and points, right? So the first thing we have to do is, what are the components? So we want to work our loop this way and back to the front. I want this component, this component, this component here, all the way back to this one. Now, what it's going to do, it's going to help me, assist me in getting the faces. And this is one of the key areas to take note of, is the tolerance stack up uses faces. So one of the reasons I bring that to your attention is that what happens if you have an insert mate? If you have an insert mate, it will not solve, because an insert mate uses edges. And any areas that have that, you will have to do a manual selection like I'm doing right now. Now, there I've finished my loop. Go ahead and select that. And there is my stack up that way I created manually. If you think about the amount of time it would take to do that by hand, or even using an Excel spreadsheet, this will make our users much more productive. And also, it's going to reduce a barrier to entry, because maybe tolerance analysis was something that, people just weren't willing to try because it was too difficult. So that's one of the key areas also, is we make it easy enough that different levels of users within an organization can take advantage of this tool, and then have advantage of all the downstream gains, especially cost in the end. Now, real quickly, I'll generate a report. It's an HTML level report. I'll just throw it out to my desktop here. We'll hit save. And I get a nice HTML printout of the results, predicted quality. The worst case scenario tells me what the quality was. and the different parts that were part of the stack up. So at this point, Kevin, Jim, do you have anything to add before I hand this off to Lars?
Just a couple of things to mention. Just want to make sure that you can hear my audio okay?
Yep.
Okay. So, well, first of all, thanks, Chris, for covering that so far. I hope everyone's equally as excited as we are about having another new addition to the collection to, one, approach customers who are already subscribed, and two, obviously all the customers that are still in maintenance or using suites that you could potentially move and use tolerance analysis as an important discussion point. So I just wanted to talk about three quick things. The first one is just to recall attention to the chat window. Is I posted a link to all the tolerance analysis assets that are currently available inside of One Team Source, so everyone can click on that and check those out after the webcast today. Secondly, make sure that everyone understands for partners, just like we have done for other collections, technology solutions, that we have to have a separate NFR that you need to order in order to get access to this. So next week, when the tolerance analysis becomes officially available on the 5th, you'll all be able to go in and order your evaluation/NFR copy of tolerance to complement and show the new workflows as part of the collection. And then the last piece, just want to make sure everyone's comfortable understanding some of the decisions we made around this functionality being part of the collection as opposed to core Inventor. So obviously today in Inventor proper, there's a lot of features and workflows that allow our customers to do tolerance-related items. So we have the model-based parameters where you can apply some basic tolerancing and run the high side and the low side through the parameters window and check for interference on parts on various manufacturing deviations and or maximum or minimum sizes. So that's one option that's in core Inventor today. Another option is as part of the design accelerators. We have some calculators in there that help customers do some similar things. And of course, we have drawings that give the ability to tolerance the drafting dimensions and the ability to put tables and do some basic tolerancing there. So there's a lot of workflows today that customers can take advantage of Inventor and Inventor Pro. But obviously, as part of the collection and the strategy we've been laying out, we want to make sure customers are moving to the collection and taking advantage of that for more advanced and complete end-to-end design and manufacturing workflows as part of the collection. So just want to lay that out a little bit, make sure everyone understands. So if you're talking to a customer and they want to know why this isn't in core Inventor, just remind them we have a lot of great investments already in Inventor for helping with similar topics and building up to this. And obviously the collections is going to be where they can do the most. But the one that crosses over between the two of them is model-based definition. So if they're doing 3DA on their parts inside of Inventor and Inventor Pro, those model-based definitions can be consumed by the tolerance analysis tool. So that's kind of the real main carryover between the two. So that's all I had to just kind of close out the tolerance topic. And I'll switch over to Lars.
All right. Can you guys hear me all right?
Yes, sir.
Perfect. And it seems like you can also see my screen. So let's see here. I got about 600 PowerPoint slides and another 58 minutes to talk about that. No, I'm kidding. I'm going to get everybody back to work quicker than that. So yeah, so my name is Lars Christensen, and super excited that you guys taking the time out of your day to join today's call. It's got some exciting stuff coming in Inventor, and I'm going to be talking a little bit about the announcement of Fusion 360 now. As you know, and I know some of you guys on the call today are way ahead of the curve, and some other people have maybe been busy with other things and haven't really had a chance to dive deep down into what is happening on some of the other product within the collection. But so Fusion is now become kind of one product. So they took the Fusion standard version and the ultimate version and combine that into one. What means that inside of the collection, you now have, and hang on, my Mac is thinking here. You now have, I'm a PC guy, so bear with me. So within the collection now, you now have one fusion available, and that one fusion is now the standard and ultimate put together. What means that now you have generative design available within that one fusion, and that one fusion, of course, is available within the collection. So, you know, as Chris was talking about and Kevin was talking about, that you know, the development team keep on, you know, working hard on all the different tools within the collection. Of course, not only Inventor, as you just saw some cool things in there, but also, of course, the other projects, products such as the HSM and the other in CAD. And Fusion is one of those tools that is now available to a collection customer. And, you know, just quickly from my perspective, you know, Inventor is absolutely the best 3D CAD tool that Autodesk has. Fusion 360 is the cloud offering. So I think that that's important to just kind of like divide it there. There's some crossover, but you know, I think that's important to kind of like put out there that Inventor is absolutely the best 3D CAD tool we have today. Now, Generative does an interesting thing because Generative design is kind of in the beginning of the design process. So it's a tool that really can give a design engineer a lot of options to choose from up front. So it's a little bit different than, for example, the topology optimization that some of you guys may be familiar with within Inventor, where you kind of shaving away from a setup of a part and kind of narrowing that down to the, you know, to one solution. So generative design, as you can see on this screen here, is kind of in the beginning of the slide, and like I said, it's totally part of the collection. So I just wanted to kind of iterate, you know, what Chris was talking about. That the collection really is an attempt to try to take the whole process from the design all the way to manufacturing within that Inventor interface that everybody is comfortable with, that everybody kind of understands, and with all the different add-ons added in there. And then you got the Fusion in there as kind of like a you know, our cloud offering, and you know, really interesting tool to make available to the collection customer. So two things that the way I look at it. So generative design is absolutely, you know, a great tool that Inventor users, collection users should definitely explore. And then, of course, also, since this is our cloud offering, you know, all the great collaboration tools that is out there. Now, when it comes to for Fusion 360 and running Generative, I'm not gonna go deep into Generative today, because there's a bunch of videos on that already, and we are actually working on the tech marketing team right now to create some more videos going from Inventor to Fusion, back and forth, and so forth. But I just want to kind of give you a quick little taste of some workflows. So one of the things to be aware of, if you're not aware of this, that generative design is inside of Fusion. So it's one of the workspaces inside of Fusion 360. Like I said earlier, collection customers have access to Fusion, so they can go and they can activate their seat of Fusion 360. For you guys, if you fill out a request an NFR license, you will get 2,500 cloud credits available to you. So generative design, uses cloud credits as a way to solve utilizing the parallel compute up on the cloud. So you need cloud credits to be able to run generative design. And just so you're aware that to run a study of generative is 25 cloud credits to run a study and get the results. And that 25 cloud credits, this probably is important for some of you guys to know when you're out talking to customers about this. That 25 cloud credits is really just to cover our cost on utilizing the Amazon servers. So there's no earnings in that regard. That is literally the direct cost to solve this up on the servers. So that's the first 25 cloud credits. This is also one of the reasons that it's not available in the student and hobbyist version of Fusion 360. I can just picture some kid in a dorm at 3 a.m. in the morning just hit generate. So there is a 25 cloud credit cost up front, and then when you go through all these different options that Generative throws at you, there's never one right design solution. It's always a trade-off between what is your manufacturing capabilities, what is your materials you can pick, and so forth. When you have filtered down that, and if you select a model you want to bring back into Fusion, that will be 100 cloud credits, and a cloud credit is about $1. So theoretically $25 to solve and get all the results, and then when you're filtering down to whatever part you want, that is then 100 cloud credits or $100 to bring that part back into Fusion. What is a full? It is a solid model you get back. It is editable with T-spline technology. So again, a little bit different from some of the topology optimization or some of what our competitors are calling generative design. If you're looking at some of our other competitors currently, when they're talking about generative design, they're really talking about topology optimization. And again, a couple of differentiators when you're talking to your customers is that generative will give. Yep.
Sorry to interrupt. I just want to double check. So there might be a refresh just on my side, but we're still at the Fusion 360 kind of like.
Yep. I'm gonna move ahead just in 2 seconds. Yeah.
Sorry.
I lied when I said I had 600 slides. I'm sorry. I really only have 2. So yeah, and I'm not. I didn't want to go in and show a lot of product today because I know that a lot of this information is out there, and like I said, we're creating some videos, but just I think some important things to just kind of like just keep in mind when we are talking generative, because you're gonna get. We've been doing a lot of generative workshops, and you're gonna get some of these questions. So really with generative inside of Fusion, you get a lot of results for you to pick from. That's one thing. The other thing is that it knows your manufacturability. This is important for most collection customers, as nobody gets paid to paint pixels on a screen. You're looking to actually make a product. That with generative design, you can not only get a unrestricted model that is kind of whatever the software kind of can generate, what we are normal to see kind of topology optimization wise, but it also understands if you're doing an additive process. So like, for example, you're doing a metal additive printing, and it will print out a model in 3 different directions of that. And then there is also in there today a so that it also can spit out for 3-axis and 5-axis output. So if you are a machine shop that only has a 3-axis mill, generative actually can incorporate that. And then the last thing is that it gives you a solid model, not just some kind of a mesh model, and that can be edited with T-splines. So yes, that was just kind of like what I wanted to share about the generative. One of the things I wanted to share with you guys is that in regards to workflows, and we're gonna get further into, like I said, we're gonna create some videos with that. But one of the really interesting ones, when you have gotten out and get your license, your NFR, with the 2,500 cloud credits, so you can actually run some studies and show this, is of course the workflow between Inventor and Fusion. And there you can utilize Fusion Team. Now, Fusion Team is accessible with Fusion, and the biggest difference is that when you just install Fusion, then you get your own account, your own username, your own account. But with Fusion Team, you can now start inviting people, collaborate, and you can invite people into different projects, and you can control, if they should have access to edit or read or whatever. So it's a little bit more, should we say, professional grade, in the sense that you can now have, different departments working via Fusion Team. And then if you are utilizing Fusion Team and you link that up with Desktop Connector, then you can actually have a very nice workflow between Inventor to Fusion. So what you're looking at on your left is, good old Explorer, and in that window there, you're looking at, over to the left frame, you can kind of see that the Fusion 360 team has been highlighted, so that will be installed right on your computer. And then you can see, if you're looking at the files, there's some folders, then there is some Fusion files, and then you will also notice that there is actually also a Inventor part for generative design in there. So from Inventor, you can save directly into your Fusion Team folder, and then if you look on the right image, you will actually see that that appears right inside of Fusion. So there's no translation right there. You pop a file from Inventor into, that directory that is on your computer, on your desktop, and it gets synced with the cloud up to Fusion automatically. And I should also say that this actually also works with Vault. So with Vault, link Vault to Fusion Team, and in that way control this. Now, what this means is that you, when you are inside of, if you save a file out of Inventor into Fusion Team, into your desktop connector, then it's connected to Fusion Team, you open it up you open up Fusion, you double click on that Inventor file, then it will use AnyCAD that is in preview right now inside of Fusion to open up that file. And now you can do generative. You could, of course, also do other things in there, but now you're in AnyCAD mode, that I'm assuming most of you guys are pretty familiar with that. And the same way back. So when you have created your output from generative inside of Fusion, when you save that file into your project, what you see on the right there, then that again will appear inside of your Fusion Team folder on the left. And now inside of Inventor, if you want to, you can utilize AnyCAD to bring that Fusion file in. So this is a really nice workflow. Now, there's other things with Fusion Team that we definitely got to do a better job highlighting. There's actually revision control in there too and stuff. So if you put in a Word document, you save it, and then you can do other things with that. So that's kind of the workflow that we are working on creating some videos on. So number one thing is that you should definitely go ahead and apply for Fusion Team, and I'm going to give you the link just in a second for that, because it's still a manual process that's going to change shortly. So you definitely want to start utilizing Fusion Team, and when you are inside of Fusion Team, what you see here on the screen to the right, then if you click up on your thumbnail, then you will see in the blue box is you can have multiple teams in there. And then down with the green arrow is where you can install that desktop connector. And when you install that, that gets synced right into your machine if you're a Mac or a Windows machine, and then you can start utilizing that workflow I just showed on the other side. But again, we're working on some videos. I think it's super nice. workflow for that. So when you install that, you hit that install the Fusion team, then you will end up having a little icon down on your desk bar. You'll sign into your account, what is linked to your Fusion team, and then that's when it will show up. What you see on the right of your screen right now, that's what will show up on your desktop. So like I said, requesting a Fusion team is still a manual process, but it is going to be changed right now. If you go out on your favorite web browser and you type in Autodesk, I guess is how you say that. So AUTODE.SK/Fusion team, then you will get the information to how to set that up right now. So you just request it and then you get it. Like I said, the team is working on getting that from a manual process to an automated process for that. That was all that I had. I had slides for today. I don't know if there is any questions for Chris or for myself, but definitely, I think this is exciting from an aspect of a collection customer that, and the way I think to positioning this is that, we have these cool cloud products we're working on, Fusion, on the Fusion 360 platform, and we definitely want to make sure our collection customers have access to these new tools and be able to utilize them.
Yeah, Lars, one quick note from me, just like Lars mentioned from an NFR standpoint from Fusion, in order for our partners to access tolerance analysis, you will need to request an NFR of that. And if you have not in the past done the same thing for HSM nesting and Nastran and CAD, it's the same process for those as well.
And I should also just add, like, if there's any specific questions you guys have, you're more than welcome to email us first.lastname@autodesk.com for sure.
Yeah, just one thing I'll add. Great job, Lars, covering generative. I think for everyone, if you haven't spent a lot of time taking in all of the generative press that's out there, and the way we're positioning it and some of the great stories, make sure you're also spending some time just taking all that in and researching that. And another way I've heard generative be positioned that I think is really powerful is that in some cases, many of our customers aren't yet, doing, let's say, some more advanced methods. They can still use generative to get some inspiration for some of the shapes that they're still going to make in a subtractive manner. So please just start, taking in this new addition to the collection, leverage it as a way to talk to executives at our customers about the way Autodesk is innovating. And, don't be afraid to sit down with some of our customers, rock star, superstar Inventor users, and show them some videos or demo live generative and get their feedback. But we want to make sure that our customers who own suites and collections understand that as we make investments in the cloud, the future of making things, that they also understand they have access to these and they can try them at any time. So thanks, Lars, for introducing it to everyone. And hopefully everyone on the call will start taking advantage of that new availability to have some really insightful conversations with your customers about new manufacturing methods.
Kevin, if we have time, I can show the video that we have created that shows a high-level workflow of Inventor and Fusion in a generative style workflow.
Yeah, I mean, we still have a couple more minutes. If anyone has any questions, feel free to type them in the chat, but we can close with that. Chris, if you want to show that video, just everyone can see it working.
All right. Give me a second. I will, Lars, you want to change presenter over to me?
I try.
I got it. All right. Close some of these extra windows I have. Okay. There we go. Move these out of the way. Okay, so really quickly, you'll notice we have an assembly here in Inventor. Basically what this is a clamping mechanism that goes on the end of a robot. In the past, if you've ever used the ASCA data set, this is an example. So what we've done is used AnyCAD and pushed that over to Fusion. Now we have set up our boundaries, what we want to preserve and what are obstacle geometries, and we're going to let the generative go ahead and calculate the different options that we have. So one of the things to take a note here is we're taking 3 parts and combining them down into one. So now what we'll do is we're using the Connect Desktop and Fusion team, or desktop connector. We're going to go ahead and bring that in as an AnyCAD piece into our Inventor assembly. And just like with a standard Inventor part, I can use joints or constraints, get it all constrained up. And there is a quick example of a workflow going from Inventor using the desktop connector and the generative functionality with Inventor, and then bringing it back through the same bridge using Inventor desktop connector back into Inventor. So what we can do, is there any questions? Go ahead and throw them in the chat window. I think we have a few minutes.
Yeah, no questions at this time, Chris.
Excellent. Kevin, you want to go ahead and wrap it up then?
Yep. Well, thanks everyone for attending today. Hopefully you're excited about the new .2 updates for Inventor. A lot of new conversations you can have with customers and remind them about, being a subscriber, all the new updates we make. Obviously, tolerance analysis is something to be really excited about and work with customers on, about the value of the collection. And of course, generative is a completely new way to inspire our customers and all the engineers on a new way of thinking, and how by being part of the collection and being a subscriber, they're part of the future of making things. And that's it. So great job, guys. Thanks everyone for attending, and have a good rest of your day. Bye-bye.